You can see factories, you can see aircraft, you can see chips, but there is one thing you cannot see: the software that makes them possible. Now, without industrial software, modern industry stops. It doesn't slow down, it stops. Every advanced product today is first built digitally. Before a plane flies, it is designed in software. Before a chip is printed, it is modeled in software. Before a car is assembled, it is simulated in software. It is designed, simulated, and tested inside a digital environment. This digital layers is called industrial software. Industrial software includes EDA, which stands for Electronic Design Automation, used for chip design. It includes CAD and CAE, which are engineering design and simulation tools. It includes PLM system used for product lifecycle management. It includes industrial control software used to operate factories. It also includes a digital twin system used to simulate real-world systems. Without these tools, nothing complex can be built. The global industrial software market is dominated by a small group of companies in ADA, which is a chip design software. The leading companies are Synopsys in the United States. Another major company is Cadence in the United States. Another major provider is Siemens EDA, which rules in both the United States and Europe. Together, this company control more than 80 to 90% of global advanced chip design market. In industrial design and simulation, the major company include Dassault Systems in France. Another major provider is Siemens in Germany. Another important company includes PTC in the United States. Another larger platform provider is Autodesk in the United States. These software platforms are deeply embedded in global industrial systems. The people often focus on chip manufacturing, but before a chip can be manufactured, it must first be designed. Designing a modern advanced processor requires billions of transistors. It requires extremely complex architectures. It also requires a precise modeling of power consumption and heat distribution. Without advanced EDA tools, it is impossible to design high-performance chips. Even small design errors can cost hundreds of millions of dollars. They can also delay production by years. Developing a 5-nanometer chip today may require $300 to $500 million in design cost before production even begins. The EDA software licensing and support can reach tens of millions of dollars per major products. For larger technology companies, any software licensing costs can reach hundreds of millions of dollars. Because without these tools, no advanced chip can exist. A modern commercial aircraft contains millions of components. It requires complex aerodynamic modeling. It requires structural stress modeling. It also requires fuel efficiency optimization. Before manufacturing begins, the entire aircraft is simulated digitally. Engineers test the wind resistance inside the simulation software. They test the thermal stress inside the simulation software. They test the fatigue cycles inside the simulation software. They test the system integration inside the simulation software. All of this happens inside the software. Without advanced simulation software, building a molten aircraft becomes guesswork. And guesswork in aviation is unacceptable. Unlike hardware, software improves through decades of iteration. It improves through massive engineering data. It improves through real-world feedback. It improves through continuous upgrades. Leading platforms have accumulated millions of design cases. They have accumulated decades of validation. They have deep integration with industrial systems. This creates extremely high switching costs. Now, once a company builds its design ecosystem around certain software platforms, changing those platforms can take years. It can also require massive retraining. Industrial software is not just a set of tools. It represents control over design capability. Whoever controls the software influences how chips are designed. It influences how aircraft are engineered. It influences how factories operate. It influences how complex systems evolve. Industrial software represents upstream influence over the entire industrial chain. In the past, the industrial power was defined by factories. Today, it is increasingly defined by design capability. The factory built products. Software defines what can be built. The physical world is now constrained by digital tools. Most people see finished products. The few people see production lines. Almost nobody seeing the software behind them. But in the modern world, whoever shapes the digital blueprint shapes the physical reality. This influence is not loud. It is not visible, but it is decisive.